Hey everyone, Teacher Chang here, and today we're going to go ahead and take a look at the area of a sector and a segment in a circle. So let's go ahead and take a look what a sector is. Now, a sector is basically the area of a circle that is bounded by two radii and the arc between the endpoints of the radii. Now, radii is the plural term for radius. So here we have two possible sectors here. The two possible sectors is either a minor sector like the one that we have here in pink, and the reason why it's known as a minor sector is because it's coming from a minor arc. And then we also have a major sector, the one in yellow, and the reason why this is our major sector is because that it's coming from a major arc. Now, how do we calculate the area of a sector? Well, that's this formula right here on the right. And basically what we need is the measurement of our central angle or the measurement in degrees of our arc. So if we take that measurement divided by 360, because there's a total of 360 degrees in a circle, and then we multiply it by the area of a circle, which is pi r squared. In other words, we're taking a fraction of the area of our circle, and that's basically where this formula came from. So let's go ahead and try this out with a couple of examples here. So if we take a look at our first example on the left, we're going to go ahead and find the area of that sector in blue. So in order to find the area of the sector in blue, we're going to take our formula, which is going to be area is equal to our angle measurement, so the measure of our angle, over 360, so that's the fraction of our circle, times the area of our circle, which is pi r squared. So if I take a look at what they gave us, the information that they gave us is that is going to be that 40 degrees, which is our central angle. So that's going to be our measurement of our angle, divided by 360. And that's supposed to be 360 degrees. And then times pi r squared. And r in this case is going to be 6 centimeters. So that means 6 squared. And all we got to do is substitute all of that in and solve. Now, depending on your teacher, they may ask you to go ahead and write it in pi form or in decimal form. So we're just going to do both of them here. Now, if we go ahead and write it in pi form, this 40 over 360, if you simplify that, that turns out to be 1/9. So now we got 1/9 pi times 6 squared is 36. And well, if we go ahead and put all of that together, well, that's just going to give us 4 pi, because we got 36 over 9 pi, and 36 over 9 is just 4. So now we got 4 pi. So that's what it is in terms of pi. Now, if your teacher wants you to go ahead and write it in terms of a decimal, well, pi is going to be our 3.14. So that's going to be equivalent to about 12.56. Now, don't forget your label. The label is area, so we have centimeters squared because it is area. So there's our first one. Let's go ahead and take a look at the second one just to make sure that we got this. Again, we're going to use our formula. The area is equal to, and I'm going to fill in that measure angle. We have 360 degrees on the bottom. We're going to do pi times the radius, which will fill in, and square. So I'm just going to substitute the information here. Well, the measurement angle that we have here is going to be 150 degrees. This time they gave us the measure of the arc, which is going to be the same thing as our central angle. So our central angle is also 150 degrees. So we got 150 degrees here. And then we have our radius, which is 9. So that's 9 squared. So we go ahead and simplify all of this. 150 over 360 can be simplified down to 5 over 12. And then if I actually did the 9 squared, that's going to be 81. So that's times 81 pi. And if we combine all of that together in terms of pi, that's going to be 135 pi over 4. Okay, and that's in simplest form. So we can write it like this, depending if you want it in pi form. Or we could go ahead and write it in terms of a decimal. And if you actually calculate it, it's going to be approximately 105.975, which we could just round it to 106. So if we say 106 centimeters squared. So again, depending if your teacher wants it in pi form or decimal form, that's up to your teacher. Now, This other example is slightly different. This time we want to calculate the radius, and they gave us the area of the sector. So we're going to go ahead and do the same thing. I'll write out the formula. So we have area is equal to our measurement angle over 360 degrees times pi r squared. And we're just going to substitute what we know. Well, we do know what that area is. That area is 135 pi. So they gave it to us in pi form. And that's actually really nice because you'll see what happens when we start calculating it. We'll eventually cancel out the pi's. Now I'm going to go ahead and put in our 360 degrees, and they gave us a major angle or a major arc here, which is going to be 216 degrees. So we're looking at the area of a major sector. So 216 degrees. Remember, major means greater than 180 degrees. And then we have our pi and then our r squared. So the r is what we're trying to solve for. Okay, so if we go ahead and solve this, I'm going to keep that 135, and I'm just going to simplify our fraction here. So 135 pi is now equal to, well, 216 over 360 is just 3 over 5. So I'm going to go ahead and write that as 3/5 pi r squared. Now that pi, we could say it's pi over 1, so I could go ahead and do 3 times pi, which is just 3 pi, and then we have our r squared. Now we could go ahead and put our r squared at the top as well, because this is r squared over 1. So if you go ahead and combine everything, this is what it will look like in terms of a fraction. All right, so now we want to get r squared by itself. Well, we want to get rid of that 3 over 5 and that pi. So to do that, we're going to multiply by its reciprocal, so 5 over 3 pi. Now what we do on one side, we'll do to the other, so 5 over 3 pi. Okay, so now we go ahead and do the math, and the pi's over here will cancel each other out. We also have our 5's canceling each other out, and then our 3 pi cancels each other out. So now if we actually did 5/3 times 135, that ends up being 225. And now that's equal to r squared. And then last but not least, to get rid of that square, we'll go ahead and do the square root on each side. So we'll square root both sides, and that way the square and the square root will cancel each other out, leaving us with r is technically plus or minus 15. But remember, we can't have a negative length, so r is just going to be the positive 15. Now, let me actually go back because we don't want to forget our label. In this particular case, it would have been units because we don't have that unit of measurement. So notice it's 15 units and not 15 units squared, because we're not talking about the area, but we're talking about the length of the radius. Okay, so that's how we go ahead and use the formula for our sector. Now let's take a look at a segment. Now, segment means a piece of something. So what we're going to do is we're going to take a look at a piece of the area of our sector. In other words, it's an area of a circle that is bounded by a chord and an arc of a circle. So what we have here is we have our chord, which is BC. In this particular case, let me go ahead and draw that right over here. So here's our chord BC or CB, and it's bounded by the arc with those endpoints here. Okay, so we're trying to find the area of this segment right over here. And in order to do that, what we're going to do is we're going to find the area of the entire sector like we did before, and then we're just going to take away, we're going to subtract that triangle that is between that segment and the radii and the two radii. So let's go ahead and take a look at how we do this. So basically, once again, here's our formula. It's the area of the sector minus the area of that triangle. So let's go ahead and try that out with this next example right over here. Okay, so here we have a nice simple one because we do have the angle measurement, and we also have the radii of 12 centimeters, and this one works out nicely, and I'll show you why. So the first step, we have a couple steps here. We want to find the area of our sector. And we already know how to find the area of our sector. We're going to go ahead and take our angle measurement, which is 90 degrees. So 90 degrees over 360, that's the fraction of our circle. And we're going to multiply it by our area of the circle, which is pi r squared. And in this case, the radius is 12. So 12 squared. Now, if we actually did the math, this ends up being 113.04. Okay, so we'll say it's about 113 degrees if we want to round it to the nearest tenth, or 113 centimeters squared if we want to round it to the nearest tenth, or if we want to round it to the nearest whole number. So we'll go ahead and say it's approximately 113 centimeters squared. Now we want to go ahead and find the area of the triangle. Okay, the area of the triangle is just base times height divided by 2. Well, this one's a nice one, because if we actually take a look at our base and our height, well, that's going to be a 12 by 12, because the radius is 12. So that means 12 times 12, or 12 squared, divided by 2. And that ends up being 144 divided by 2. So that's 72 centimeters squared. And that's the area of the triangle. And then the third part is to go ahead and just subtract those two values. So we take the area of our sector, which is 113, and we're going to subtract it with the area of our triangle, which is 72. And that's going to give us the area of our segment, and that's going to give us approximately 41 centimeters squared. Okay, so that's the area of that particular segment. Let's go ahead and try another one, but this one's slightly different. And the reason why it's different is because, well, it's not a right triangle, and therefore we can't really find that base and that height. Now, we could go ahead and figure out the base and the height by using what we know in terms of trigonometry, or in this particular case, we could do a 30, 60, 90. But here we also have a formula that will always work for the area of non-right triangles. And you can see that at the bottom left-hand corner right over here. And this will always work. Now, this will require you to use your calculator, because we do need to find the sine of our angle C. So let's go ahead and start this off by finding the area of our sector. So to find the area of our sector, again, I'm going to write out that first part. Area of the sector is going to be, in this particular case, our measurement angle, which is 120 degrees. So our measurement is 120 degrees over 360. And then we're going to multiply it by the area of our circle. So pi r squared, r is 9, so 9 squared. Okay, you calculate that, and we're going to use 3.14 again for pi. That's approximately 84.78. And I like to round it to the nearest tenth, so I'm going to say it's about 84.8. Okay, so 84.8 centimeters squared. I'm going to come back to that. We're going to go ahead and find the area of our triangle now. So to find the area of our triangle, we're going to use this formula that we see here. So it says we're going to do 1/2 of A and B. So A times B. In this particular case, A and B is always going to be our two radii. So we have 9 here and 9 here. So that means 9 times 9, or you could do 9 squared. It's going to give you the same thing. And then it says sine C. Now that C is our angle measurement. So sine, that angle measurement of 120 degrees. Okay, so now we just go ahead and type that all into our calculator. We could type it in, and I'll show you how to type it in really quickly. You could type it in exactly as it's written if you have a nice graphing calculator. So I'll show you how we do that. Let me move the calculator over to the other side. That way we can see what we're typing in. Okay, so we're going to do alpha y equals, and we're going to choose the fraction. And the fraction is 1/2. You could type in 0.5 if you want. Now 9 times 9 is 81, or if you want to go ahead and put it in exactly how we wrote it out, that's fine. And then we type in sine, and then we have 120 degrees. Now, before I do this, I'm going to make sure that we're in the degree mode. So if I take a look at this, I am in the degree mode. Okay, so make sure you're in the degree mode, and then we'll click enter, and we get about 35.07, or we'll say about 35.1. Okay, so that's going to be the area of our triangle. Okay, now that we have the area of our triangle, we're just going to subtract the two. So we're going to take the area of the entire sector, which is 84.8, and we are going to subtract it with the area of our triangle, 35.1, and that's going to give us our final area of approximately 49.7 centimeters squared. All right, let's try one more just for good measures. Make sure that we know what we're doing here. So let's take a look at this last one, and I'm just going to slide this all the way down. Okay, so if we take a look at this next one once again, we're going to go ahead and find the area of the sector first. So that's our first step. So the area of a sector is going to be taking our angle measurement, which is 100 degrees, over 360. That's a full circle, so this is a fraction of our circle, times pi r, in this case is 50, squared. Okay, so we're dealing with some larger numbers here, and if we actually calculate that, that's going to be approximately 2,180 and 0.5. That continues, that repeats. So we'll go ahead and round that to about 2,180.6. Okay, this is also in centimeters, so centimeters squared. So that's the area of our sector, not a problem. Let's go ahead and try the area of our triangle now. So the area of the triangle, I should say this is the sector. Okay, so the area of our triangle, again, this is a non-right triangle, so we're going to go ahead and do 1/2 of A times B, which is going to be our 2 radii, and then we have sine angle C. Okay, so this is C degrees. Okay, so let's go ahead and plug all that in. So our A and our B is going to be the radii, which is going to be 50 and another 50 over here. So this is our A and our B. So you could do 50 times 50, or 50 squared. And then we have our sine C, and that C is going to be that 100 degrees. Okay, so again, we'll go ahead and type all of that in your calculator. And remember, we want to make sure that this is in the degree mode. So let's go ahead and do this really quickly. Again, make sure your calculator's in the degree mode before we do all that. So I'm going to go ahead and type this all in. So alpha y equals, to get our fraction, we'll do our 1/2. And again, you could do 50 squared, or you could do 50 times 50. And then we have our sine, and then we have 100 degrees. So I go ahead and enter that, and we get about 1,231. So if we round it, it's going to be approximately 1,231. Okay, so now that we have the area of our triangle, all we got to do is subtract these two things. So let's go ahead and do that last step, which is step number 3. And that's just to subtract the area of our sector, which we stated earlier was 2,180.6, and we're going to subtract it with 1,231. And when we do that, we eventually get about 949.6 centimeters squared. All right, so that's how you find the area of a sector and a segment. I hope this helped out. If you have any questions, go ahead and leave a comment, and don't forget to like the video and subscribe. If you want to, if you really liked it, go ahead and share this video with your friends and family as well. All right, good luck, enjoy, and have fun.